Welcome back to the channel, everybody. Today's video, we're going to be going over petrified wood, how it's formed, what it is, and more importantly, kind of what it isn't. And as with the agates and jasper explained video, this is not the place to get super hung up on all the vernacular. And if you're the type of person that wants to be like, well, actually, you can go kick rocks, or in this case, you can go kick some wood, some really hard wood. So let's, I got some rocks here. Let's look at these. Let's talk about some petrified wood. Here I have a collection of petrified wood, all of which has been collected by me. There's definitely more colorful and pretty petrified woods out there for sure, but this is what I have collected so far. It's by no means all of it, but I think a good representation of my collection at this point. Now, there's 4 rocks here on this table, not my coaster, 4 rocks here on this table that are not petrified wood. Are you able to look at this right here and figure out which 4 are not petrified wood? Maybe you can, maybe you can't, but I will let you know at the end of the video which 4 are put here to kind of trick you. My reason for this is to kind of show you how difficult it can be for a visual-only identification. Now, I get a lot of emails every week of people wanting help identifying their rocks, and I learn a lot from this, so I really appreciate it. But there's always somebody that has a rock that is not petrified wood, and they believe it's petrified wood. So I think we can kind of delve into this some and maybe clear up some of the muddy waters for people. Let's start with a real quick explanation of what this petrified wood is and how it came to be. So the TLDR of it is you got to have some organic material, like, wood, something like wood. You got to encase it in a sediment, so there's a lot of ways that you can encase something in sediment. And then you got to have dissolved minerals like silica, dissolved in that water, and it's got to flow into the organic material and replace the material with minerals. That's the gist of it, right? So some of the different things that could happen, right, that would cause wood to petrify would be like a volcanic ash fall, your mudslides, lake sediments. Think about it like this. You got to have a tree. It's got to go blump on the ground, and it's got to get buried. It's got to be underwater. It's got to be in that oxygen-free environment with a lot of water present. And that's basically it, right? Dissolved minerals move in and slowly over time replace that organic material with the whatever minerals were. And the minerals, they vary a lot, right? Like your carbons, irons. A lot of the wood out here is replaced with silicon dioxide, which gives you this white appearance to it. So the neat thing about petrified wood is that not all of it's always going to look the same. And because of that, it really trips people up, But you got to think, right? This was a living tree at some point. So like knots, bark, bugs burrowing into it. Maybe the petrification took place really slowly. So it's kind of this like gnarled, scraggled up thing. And, you got minerals moving in, so you can get stuff like pyrite cubes in it. This piece right here, right? Does it pick up on camera? We got this druzy on the outside, and you can see right there that this had a void in it, or maybe the petrification just didn't take place there soon enough, and it straight up just rotted away slowly. And, that's we got bark on the outside here. There's different knots. Little limb casts. It can be really cool material. So, one of the big problems that we have is with the identification of petrified wood, because we know like this piece right here, okay? So this is from the Yellowstone River in Montana. I can identify this as petrified wood in a number of ways, but right? These two things look very different, right? Like, how do you determine that? What are the determining factors here? Typically, you're going to be having a really hard material if you have petrified wood. Doesn't matter if it came from Saddle Mountain in Washington or Arizona or Southern Oregon or Australia. It's for the most part going to land in a hardness of like 6.5 to 7.5. That's when you got to have some way of testing it. You got to have a hardness pick set, just like this right here. I got this from Mineral Lab, but other companies make these as well. They're kind of a more pricey item. Like this guy right here, I think it's $120 right now. But if you're going to be getting into identifying rocks and stuff, it's something you definitely want to invest in. So you need these really specific conditions to get this stuff to form. And that's why you can have this big variation in it, and it's really cool. Like this piece right here, right? This piece is from Saddle Mountain. Now, some people would call this agatized. Some people would call this opalized. This kind of a good example of why it's not a good idea to spend your free time trying to correct people on this stuff. It is a waste of time, in my opinion. You can see we have some kind of poorly formed common opal here. We have like some little botryoidal bits. It can be really interesting stuff. So, if you really wanted to get technical about it, I'd probably say that some of these areas in here are more in that that range of being an opal, a common opal. And we have some pieces in here that are clearly more in that realm of being closer to chalcedony, that agate type material. But that doesn't really matter a whole lot. Now, if you have stuff moving in like your silicas, right, you can absolutely get crystallization on here, just like this piece right here. Now, this is a piece from Hollywood Ranch in Southern Oregon. I mean, if you just saw this, I just was like, here, look at this photo of this. You may not be able to identify that as petrified wood. Not everything is going to have the same level of cellular replacement, okay? So you got to think as these minerals move in and replace the organic material, sometimes it can do a really good job and sometimes it could do a really bad job, A good example of that would be this piece right here, where you can definitely see the grain of this wood, okay? Very clear. You can count the growth rings on it. You can have stuff like this where you really, really can't, okay? I mean, that you're not counting growth rings in this. So, different levels of cellular replacement. This piece right here would be the knot of a tree. Another piece from the Hollywood Ranch in Oregon. Hollywood Ranch does have some very interesting petrified woods. Like, here's one more piece from there. And you can really see that this was, kind of on that outside of the tree. Imagine if you continued this kind of arc around in which it broke. We have great cellular replacement. And we have like a little pocket of what appears to be some kind of agate chalcedony in there as well. This is another great example of maybe there's already these voids in the wood when the tree went down, and therefore that was duplicated when the petrification took place. So I think you kind of get it, Let's talk about which ones here are not petrified wood. Well, we have this right here. This is a sedimentary rock that I picked up from the river, okay? Now, it has that appearance, does it not? I mean, you could take a photo of this at this angle and be like, well, are those the bands of trees? I mean, a good way, the surefire way is with testing hardness. These types of rocks will always be softer. Hope you picked this one. This is a good one to trick people with. I like this one because we have some really faint banding in it. But once again, we have a metamorphic rock here that's been river tumbled, and it kind of exposes some of this banding in here. This layers, not petrified wood. This is very soft material. I can't remember. I think I tested this one at like a 4 or a 5. So very soft stuff. Another sedimentary rock that made its way into the river and got kind of tumbled up. Another soft one. But if you look at these, right, let's, can you see we got banding in both? This one, not petrified wood. So I can see how people get confused by this. We got one more here. And this is just a random river rock that I picked up. Not petrified wood at all. I just kind of threw it here because I thought it could distract you. So hopefully people, you picked these 4 rocks. These are what a lot of people would consider junk. So, you know, there's that. And so right here we have Saddle Mountain, Hollywood, Saddle Mountain, Hollywood, Saddle Mountain. And here's a piece from Hollywood, another good one with some quartz on the outside. And a piece from Montana. So, I hope you found this to be useful. Maybe you learned something. If you did, you could hit that thumbs up button. Subscribe to my channel if you learned something from this and you like this content. I got lots and lots of content up here just like this. Educational videos, rock hounding videos, lapidary. Go to the main channel page. Check it out. You will not be disappointed. We have well over 200 videos here covering every aspect of rock hounding. So, hey, take care, everyone.